Okay, so we are team number 5 and we are going to present our STEM project that it's about eco-globes. Our project will be about globes that biodegrade with water while it releases nutrients into the water. This project will have a lot of utilities, and the SDGs that are related to our project are clean water and sanitization, and sustainable cities and communities. Our project proposed the creation of eco-globes that are, as I mentioned before, are biodegradable globes that are made from natural materials such as starch, glycerin, vinegar, and water. Unlike the conventional disposable globes we see in stores, eco-globes are eco-friendly and they are designed to degrade naturally in aquatic environments without leaving harmful microplastics.
Why and how the problem relates to these SDGs? This problem is related to our SDGs 6 and 11 because our project focuses on plastic polluting and invading ocean waters. Prototype functionality. Our project is made by biodegradable materials that dissolve in water. When the globe comes into contact with water, the structure begins to break down naturally. During this process, it releases non-toxic nutrients that can benefit aquatic animals. The components are starch, that is the main base material. Agar-agar acts as a natural thickener and stabilizer. Glycerin works as a plasticizer, and vinegar that helps blend ingredients and improves the material consistency. Impact and applications. Aquatic animals will stop dying from ingesting plastics. Socially, it will mean more people will buy these gloves to avoid polluting. Economically, people will no longer spend money on deep cleaning the oceans, and people who work in laboratories, students, people who clean, dentists will use this prototype to avoid further ocean pollution.
Now we have the process and development. First, we have the materials, that is water, agar-agar, potato starch, glycerin, and vinegar. And now we have the main stages of construction of our prototype. That is, the main stages of prototype were by heating the mixture and spreading in the globe mold. First, it was very important to heat the mixture with the exact measurements and the low heat, and having to beat it a lot constantly so that the mixture will not overheat was a process very dependent on whether the consistency we wanted or not. And because cautiously we had to cover the whole mixture with consistency of like a hell on the globe carefully, since we did not want a very thin or very thick layer to be made, and at the same time we had to move to cover the whole globe. Next we have the demonstration, and now we have the testing. In the testing we have the variables, description, measurement unit, measurement method, and results. In variables and descriptions we have independent and dependent variables. First, in the variables we have the independent, that is starch, latex context, glycerol, temperature, time, and environment, compost water. In the independent variables we have mass loss, degradation rate, half time, tensile strength, elongation, and fish mortality. In description we have starch, latex, glycerol, material composition, temperature, time, and environment, test medium. In independent, we have mass loss, material decay, degradation rate, solid of decay, half time, and the measurement unit we have percentage, Celsius, days, millimeters, MPa, pH, grams, and the measurement method. Now in the measurement method we have independent and dependent variables again. In the independent variables we have starch, latex, glycerol, weight, temperature, thermometer, time, environment, compost water again, and film thickness. The independent we have mass loss, weight, half time, from cover, pH meter.
For analysis, we have bad results. As a result, we found that gloves stretch very well, demonstrating reliable elasticity, and that the gloves are non-toxic. According to our results, the gloves were able to stretch in a manner similar to a regular latex gloves. This is possible thanks to the glycerin, a natural plasticizer, combined with a potato starch. Additionally, gloves are non-toxic as the materials we use are either natural or non-toxic. Next, we have the environmental problem that normally the water is very polluted by generated plastics or trash that are not ecological and can damage a lot of water, and that plastics can dissolve or do something good with the environment.
The gloves are made of starch, glycerin, vinegar, and water, and upon contact with the water, over time start disintegrating because they do not have any waterproof coating or any treatments against it. So water breaks down the hydrogen bonds and between starch chains, especially when heat is added. And then some relevant chemical reactions are the formation reactions, which are starch granules plus water plus heat become gelatinized starch, and if you add glycerol to that, you have plasticized matrix. Then the hydrolysis, which breaks the bonds between the repeating units of glucose in the starch polymer biodegradation. Then after hydrolysis, microorganisms break down the monomeric sugars. Then the effects of salts in seawater are that sodium and chlorine ions interact with the hydroxyl groups in starch and glycerol. They reduce hydrogen bonding between water and starch. This slows swelling and dissolution. Chemical reactions. How these reactions help quantify the problem? They help by giving the bioplastics their biodegradable properties, by linking them to measurable things like degradation rates, strength, and microbial breakdowns. We can quantify how well bioplastics solve the problem of plastic pollution. Then, how the analysis supports finding a solution. The analysis links the chemistry to the environmental outcome. This scientific understanding supports finding a real solution because it shows how and why plastics work, and how to improve them, and how to prove their benefits quantitatively.
Finally, in conclusion, we have that our gloves meet our main objectives, which were to achieve the stretchability similar to that a regular glove, providing a comfortable feel. At the same time, they fulfilled our most important goal, ensuring that these biogloves are non-toxic to the various marine life species found in the ocean. And to finish this presentation, we have the references. Thank you for watching.